Welcome to Remote Trigonometry. Trigonometry is the mathematics that's behind the light that we see, the sounds that we hear, the structures that we build, the molecules that fit together, and how our world turns. A worthwhile endeavor. In this episode of Remote Trigonometry, we will be looking at solving a sine or cosine equation set equal to a value. We're going to be doing an example with cosine, but the process is fairly similar with sine. You just have to watch how you get the second solution. And in a different video, I go over how to figure out the second solution if you're using cosine versus if you're using sine. Here we have a model that gives us the average low temperatures in St. Louis. So notice the average low is in the middle of January and is negative 25 or positive 25, not negative 25. And the average low temperature is in the middle of July and it's 71 degrees Fahrenheit. We're going to solve for when it's equal to 40 degrees Fahrenheit. So we're going to find when in the year the average low is 40 degrees. The model for the temperatures, the average low temperatures in St. Louis, is an amplitude of 23. We're using cosine. The wavelength is 365 days, so the frequency is 2 pi divided by 365. July 19th is the 200th day of the year, so we shifted the graph to get a maximum at 200. And then the middle, the line of equilibrium, is 48. So we're going to be setting this equal to 40. So we will be solving the equation. 40 equals 23 cosine of 2 pi over 365. X minus 200 is the quantity, and 48 is the line of equilibrium. Solving any equation means you're unwrapping all of the operations to get to your variable. So start from the outside and work through the order of operations kind of in reverse. I'm first going to get rid of adding the 48 by subtracting 48. And so 40 minus 48 is negative 8. And then that's equal to 23 times cosine of 2 pi over 365 times the quantity x minus 200. And then we're going to undo the multiplying. So the opposite operation of multiplying is dividing. So I'm going to divide both sides by 23. And I get cosine of 2 pi over 365, still times the quantity x minus 200. And then I'm going to undo cosine by using inverse cosine. So inverse cosine of the value negative 8 over 23 is going to equal what was inside of the cosine. What was inside of the cosine is 2 pi over 365 times the quantity x minus 200. Now my calculator is going to give me one value for this answer, but if you look at our wave, we can see we have a solution here, we have a second solution here. So my calculator is really only going to help me get this one. I'm going to have to reason out that one. But let's get the first value from the calculator. So inverse cosine of negative 8 over 23. And remember to have your calculator in radian mode. We're not working with degrees here. So the value of arc cosine or inverse cosine of negative 8/23 is 1.926. And so I will copy that down. So this is 1.926. And that equals 2 pi over 365, x minus 200. But we saw that there was a second solution. So remember with cosine, cosine of theta equals cosine of negative theta equals cosine of 2 pi minus theta. All of those are going to give us the same value. This is the one that's actually going to help us with our wave, because that second solution was further down the wave. It wasn't back that way. So this one won't be as helpful. We could use that one, but then we'd have to add the wavelength. This one will provide one less step. So I'm going to also find 2 pi minus theta. This is my theta. Okay, so this is my theta, and 2 pi minus theta is 2 pi minus the 1.926, and that is approximately 4.357. Okay, so both of these values then are equal to what was inside the cosine, and this was what was inside the cosine. I'm still trying to solve for x, so keep undoing the order of operations. I need to undo this multiplying, so I'm going to take the 1.926 and I'm going to multiply by 365 over 2 pi, and that will equal x minus 200. And then I will also do 4.357 times 365 over 2 pi. And that's another option for the x minus 200. Let's get a decimal approximation of each of those values. This is 111.88. And the second solution is 253.10. And now we're in the home stretch. To get x all by itself, I'm going to add 200. So this is going to give me 321.88 because I add 200. And when I add 200 here, I get 453. And you know what? I lied earlier, because we actually are going to have to subtract a wavelength, because we know there's not 453 days in the year. So we actually should have used the negative theta. So the wavelength was 365. So if I take 453 and I subtract the wavelength of 365, I get 88.10. So at 88 days, we hit an average low of 40. And at 321 days in the year, we also hit an average low of 40. So going back to our graph here, there was the first solution, and here was the second solution. Those are the same values that we had. So you can see this, I guess, is in March, and this is late October, early November is when that date would be. What I was saying about the negative theta, if we had found cosine of negative theta, it would have still equaled that same value. So if I had taken negative 1.926 and multiplied by 365 over 2 pi and then added the 200, you would have also gotten that 88. So I could have used negative theta. I used 2 pi minus theta, and I still get the same value. It's just I had to subtract one wavelength.